Hi everybody, my name is Bolor, and today I'll be talking about AI red teaming and really kind of jumping into what this term means and some different tools and techniques that we use, as well as how automation can really help these efforts. So I know that you just listened to a talk a lot about different AI safety and security harms, and so kind of going off of this topic, I'm going to go into kind of a specific case study really showing how we could potentially try and misuse AI. So in this case, we look at kind of using AI for this nefarious use, seeing if we can get AI to help us to make illegal drugs. And so to approach this question, we take a pretty simple approach. First, we go to our AI, which is ChatGPT in this case, and we ask if we can get instructions on how to make meth. So you can see we're pretty direct and clear with this question. We're not really trying to be creative. And what we learned pretty quickly is that there are safety policies in place which will prevent us from getting the information on generating illegal information like making meth. And if we substitute out meth for another illegal drug, something like cocaine, we'll be met with kind of a similar refusal to our request. So if we kind of take another approach to thinking about this question, we can do a pretty simple thing where we actually translate our question into a different language. So here we choose Mongolian, which is my native language, and Mongolian is a low-resource language if you don't know anything else about the language. So essentially we can ask this question of how to make illegal drugs, and you can see we're just as clear and explicit in Mongolian as we were in English. And then what we get here is we actually get a lot of information and highlighted our kind of steps on making cocaine and methamphetamine, which you'll remember when we asked in English pretty directly, we were met with the safety filter. So already you see this big difference just looking at different languages. And then taking this example one step further, what we can see happens is we can kind of continue this conversation, which we've started in Mongolian and gotten, again, that kind of harmful content, and we can flip back to English. And again, when we asked this exact same question in English the first time around, we were met with the safety filters. And this time, after we've gotten the information in Mongolian, we can see this information generated on the production of cocaine. So you can see in this pretty simple example how we can just alter the language and how this really makes a difference in getting around the different safety filters that exist. And so this really brings us into kind of like, this was an example of what we do as an AI red team. And essentially, even though there are different definitions floating around about what AI red teaming is, kind of the core of what it really is identifying these risks and failures within generative AI systems. And as we identify these risks and failures, what we can do is we can really try and mitigate these harms so that we can't continue to kind of abuse those. And so jumping into kind of defining what these risks and harms that we look at, we have kind of three big buckets that we look at. So first we look at these traditional security vulnerabilities as well as adversarial machine learning. And all of these topics have been really prevalent in security and machine learning for a long time. And so for today's talk, I'm really going to focus on these content safety and responsible AI concerns. And so I'm going to focus in on two kind of specific areas of looking at content safety. So obviously, we want to ensure that our artificial intelligence is acting responsibly and not creating kind of dangerous content. And so I've already shown an example of AI producing instructions on illegal behaviors. So we want to make sure that AI isn't helping us do things that are breaking the law. And then another area that I'll show a short demo about is looking at non-consensual imagery. So we want to make sure that we can't use AI to create images of people without their consent. And then even worse, we want to make sure that if we're looking at sexually explicit imagery, for example, that this doesn't get produced using AI. So a few quick techniques. First and foremost, we have this idea of AI jailbreaks. And so what this is essentially just ways that we can get around our safety filters. And so here shown on the slide is a pretty simple example. So first, you can see the system with instruction to not generate harmful content. And when the user probes and asks how to build the bomb, you'll see that the system refuses to engage. Using a pretty simple method, the user can just kind of encode their word of bomb. In this case, you just can see the ASCII art. And you'll see that the system this time gives them the instructions. So this is a simple, successful jailbreak, and you can use a lot of different ways of encodings, anything from translation or, again, making like this ASCII art. You could base 64 encode or a really large number of different ways available to you. And you can also see how you can just encode part of the prompt or all of the prompt, and those can all really make differences. And so jumping into kind of this idea of multimodal models, since we know that we have a lot of different models that take more than just text as an input, we can look at this application that basically takes in a hand-drawn image. So here we drew a little picture, and we also can tell the AI system what we're actually trying to draw or kind of critique and say what we want our picture to look like. So here we've tried to draw a cartoon dog on top of a mountain, and now our AI system kind of makes a much nicer artistic rendition of our picture, and we're hopefully happy with that. So if we take kind of an AI red teaming approach towards this, what we can do, and a quick small content warning, is there's pixelated nudity. It's definitely pixelated, so nothing too bad, but look away maybe if you don't want to see it. So a quick experiment that we did is we took this picture drawn with two people, and then we gave it kind of a long text input, which I'm not going to show here. But what happened is we can see this kind of sexual scene that was produced by AI. But what was really interesting is we took that exact same text prompt, and then we just inverted the colors. So everything else stayed the same, minus the inversion of the colors. So now we have a black background and kind of this white picture, as you can see, instead of the other way around. And what was produced was this extremely graphic sexual scene. And so we found this to be pretty consistent with this model specifically that we were testing. But this kind of shows how you can really alter not just the text, but different input modalities, and really small things like changing colors can really make a big difference. And then lastly, I wanted to touch on kind of harms being available over time. So a lot of the examples that I just showed you were kind of single turn, meaning that you have one kind of user request that gets sent to the LLM, and then one response that occurs as a result. But through a lot of different LLMs, we can actually have a full conversation. And so what we can do is we can take a potential harmful objective that we have and kind of break it up into more benign pieces so that over time we're able to see the harm. And a quick example of doing this is we might, thinking back to our example of making meth, we can perhaps break this into first setting a context, saying maybe you're an organic chemistry student, and this seems like a perfectly valid background for somebody to have, and then maybe over the course of a conversation, you ask kind of more questions about solving some different problems, eventually getting to the problem of creating meth, and now you can see that the system might be more likely to answer you versus if you just directly go straight off the bat asking for meth synthesis. And so all of these different ways you can see are really powerful ways of looking at AI red teaming, but one of the big limitations that we face is that when we do this with a manual approach, it really is time and resource intensive and gets kind of difficult when we talk about all of the different harms we can probe for, as well as all of the different applications. And so we really face this kind of resource limitation, as well as really facing problems repeating experiments, especially considering that LLMs are probabilistic in nature. This means that when you give it an output or input, you're going to get a different output each time. And so what the output differs, meaning we really want to see these patterns over the span of multiple experiments and see kind of if there's a pattern to getting a harmful prompt or a harmful response. And then lastly, you can see that this is very difficult to scale if we're talking about a manual process. And so to look at this problem and some solutions, we really turn towards automation. And so this specific tool that we have developed specifically for automating a lot of the processes of AI red teaming is called Pirate. And what Pirate is it's an open source automation framework to red team kind of AI models. And what it really brings to the table is this ability to automate different attack techniques and strategies. And what that does is when you move the attack technique and strategy away from being a manual process, you really gain efficiency as well as reliability, because now you can kind of take each of these automation components for your attack and reuse them for different workflows. And then this lets you really repeat experiments and work in this iterative fashion. And then obviously we wanted to keep in mind flexibility and make sure that the tool is very flexible and customizable based on your needs. And so jumping more into what that looks like and how this works, first I have this architecture. And so I'll walk you through the pieces of it. So first, we have this data sets component. And what that looks like is essentially the prompts that you're wanting to test or use and see if those will produce a harmful output. And so you can store them as data sets, and this also allows us really to tap into the open source kind of library of being able to use jailbreaks and prompts that are publicly available, as well as giving you the choice to use your own internal data sets as well. And so all of these are, again, stored as data sets. And then skipping kind of forward a little bit in this diagram, what's going to happen is we have our second component called the converters, and these are just your ways of doing encodings or different prompt transformation. So this is how we can do things like translation or just, again, any way that you're taking one prompt and turning it into another form. And then you'll send these converted prompts to your actual target, which is your endpoint that you're testing. So this can be your text-based like model, something like OpenAI, or it can be multimodal, taking in different images or audios or videos. And then we have these scoring engines, which are the automated way of evaluating the actual response that happens from the target. And so what will happen is you can configure kind of what you're looking for with the score and define what you think is harmful when you're running this experiment. And then you'll get from the scoring engine both the response from the target and then an evaluation of whether or not it was considered harmful, and also an explanation as to why it assigned the score that it assigned. And lastly, all of these pieces kind of fold into the orchestrator, and this is the actual kind of end-to-end automated attack. So it uses all of these pieces to essentially automatically conduct this attack. And then kind of shown on the bottom are other components of memory, which is storing all of your conversations and interactions as you're using Pirate. And then lastly, we have a lot of different demos and really walking you through really specific different use cases within our notebooks. And so putting all of this together in a more visual way, basically what can happen as an AI red teamer is first you can identify the harm that you're trying to test for. And then you can learn about your actual model and learn about the input modality of your model, as well as different parameters that you may or may not need. And then you'll choose kind of your attack method. And then kind of visualize here are showing maybe your attack includes rephrasing your prompt, and on top of that, a translation. And so also what's shown here you can see is you can kind of stack components on top of each other. So you're not limited to just kind of one conversion, for example. You can stack kind of as many as you want or need. And then of course there'll be an automated evaluation to see if that response was considered harmful. And so comparing, again, what this looks like kind of manually, just so you can really see how this is difficult to do manually versus what an automated method brings to the table, is in a manual workflow, you have your user, and your user will send your prompt. And they'll send it to their target LLM and get back a response. And then this will kind of continue in a loop and for every harm and every category that they're wanting. So you can see that this becomes pretty time intensive and pretty tedious pretty quickly. So doing this in an automated way, one immediate kind of benefit that you can see is now you can send all of these prompts using automation. You can send, a lot of prompts a lot quicker than you could do manually and get an evaluation on whether or not that was harmful, as well as the reasoning as to why it was scored that way. And then really jumping into kind of this full automated attack workflow, I'm going to walk through this kind of diagram in some steps. So let's say first we choose our overall harm objective that we're testing. So in this case, we're going to say that the harm that we're looking for, we want to see how we can generate a Molotov cocktail. And so we have this automated, you'll see step one is this adversarial chat target. And this is really your adversarial LLM, which is generating a new adversarial prompt based on your initial objective. And you can kind of give it instructions or set a specific attack technique, and it'll follow that attack methodology in order to generate its adversarial prompt. So here in a simple example, we could take our overall objective of creating a Molotov cocktail, and now instead of directly asking for that, maybe the adversarial prompt generated is instead asking about the history of these Molotov cocktails. And then Pirate will send this prompt to the objective target, and then let's say the response from the target you get is telling you about the history of Molotov cocktails, telling you that they were used in the Spanish War. Then we have this automated evaluation method, which will evaluate the response and determine that this doesn't actually meet our initial objective, which was getting steps on how to create a Molotov cocktail. And so in this workflow, you can see kind of one turn of what happens. And so clearly, if we had met our objective, our attack would now be over. But in this case, you can see we haven't met our objective, so we can kind of continue in this automated loop. And so what will happen is the adversarial chat target gets this response back from the scorer, which tells it that we didn't meet our overall objective. And so using that information as feedback, now the adversarial target can kind of try a second time to generate another prompt. And in this step, in a simple example, you can see now maybe the adversarial prompt generated is asking specifically about, in the historical context of the Spanish Civil War, how these Molotov cocktails were created. And if our objective target responds and gives us these steps in the historical period of the Spanish Civil War, again, we can evaluate this automatically, and then now we can see that the score might tell us we now have the steps to make a Molotov cocktail. And so this would then conclude the attack since we've met our objective. And then kind of showing how this looks like in code specifically, you can see kind of highlighted first is the user objective, which is how to make a homemade bomb. And then what happens is the adversarial prompt kind of generated is asking about the chemistry behind common household cleaning products. And then you'll see a secondary conversion on top of that, converting this into Unicode. And then you can see the assistant responds, and so this is the actual target response to this question. And if you're paying really close attention, your question might be that, does this response actually meet our initial objective of making a homemade bomb? And so this leads us into kind of our main challenge that we have using automated attack workflows. So it really lies in using these LLMs as scores. And we really need to be able to figure out if a response was kind of harmful according to our objective. And so it becomes kind of difficult to balance the line between choosing false positives and false negatives. And what it kind of boils down to is really having well-defined policies. And so it's especially important when we look at things that are really subjective. Like if we look at hate speech or offensive speech, it's pretty hard to determine what speech might be offensive to one group versus what might be offensive to another group. And so for all of these categories, we really need these policies which tell us what's considered an actual harm in order for us to be able to use these automated methods. And then when we add kind of specialized content on top of that, things like chemical knowledge, for example, of building a bomb, or legal or medical knowledge, you really need kind of expertise knowledge in order to set these policies and really determine what's considered harmful versus what's not. And then lastly, I'm going to walk you through this little demo, just showing how all of the pieces kind of come together. And so using this game called Gandalf, this is a game, if you've ever played, a way to practice your prompt engineering skills. So your goal every level is to just ask for the password and to gain it. But each level gets a little bit more difficult with its safety filters, so you've got to be kind of more creative each level in generating your prompts. And so using Pirate to kind of demo how these pieces work. First, what's not shown in this video is just setting kind of our attack technique. So essentially, we give it a set of instructions to tell our adversarial LLM how to generate its adversarial prompts and the attack method that we want. And so then what happens, Pirate will actually run all in the notebook, but the text I know is hard to read, so I'll paste it, copy paste it into the actual UI. So you can see the first turn, you'll get this prompt, and when you type it in, you'll see you're not successful getting the password. And so this is kind of turn number one that's occurred. And now that you weren't successful, the adversarial bot is kind of iterating and discovering a new prompt to try and send in order to get the password. So you'll see this kind of longer and better prompt that is generated. And when we type that into the UI, you'll see that we get a password. And now you'll see that the attack is kind of concluded, but just to prove to you guys that this is indeed the password, I'll also kind of show you putting it into the flag area just to show you that this is indeed the correct password. And so this is kind of, again, a way that you can use automated methods to conduct your attacks. And of course, you can use your own endpoints instead of Gandalf, but just, again, a gamified way. And so key takeaways I hope you take away from today is first and foremost that AI safety and security is extremely important, especially as we have increased AI. And AI red teaming is really kind of the way to identify all of these different harms and risks within your products. And then secondly, AI red teaming is very difficult as a manual process. So as a method to kind of make this scalable and an efficient process, we really need to turn towards automation to help us out. And then a big thank you to all of the Microsoft AI Red Team, as well as all of you for attending today. And then I want to open the floor to questions.